Okay, now we're prepared to talk about what constitutes sample evidence. So remember, we said sample evidence is ultimately what drives our decision of rejecting a null hypothesis or failing to reject a null hypothesis. So this, at its basis level, is the random sample itself. So from our population, we've drawn some random sample of measurements, typically quantitative at this level. We haven't begun talking about how we would do this with categorical data, but we could. And from this random sample, so another layer down, we take a point estimate for the parameter that we're examining a claim about. For instance, if we're examining a claim about a variance, then from this random sample, we would extract a sample variance. So there are some parallels that are starting to emerge here from last chapter and this chapter. And for that, there is something to that because we're going to be using the sampling distributions that we use for constructing confidence intervals. So fundamentally, what we're doing here, null hypothesis significance testing, is about the question, given our sample evidence and assuming the null hypothesis is true, so assuming H0 is true, how likely is it that we obtained this sample evidence by random chance alone? And as you might have guessed, the words random chance indicate that we will be using probability and all those mathematical tools for assessing the evidence. And if alpha is our level of significance, then this is our threshold for determining whether a result is statistically significant. The result is statistically significant if that probability, which will denote P, we'll talk about that later, is less than alpha, the level of significance. So P is this probability, and alpha is the level of significance, as we discussed in the previous video. So how do we get P? How do we get all this? How do we tie in then the mathematical background? We need something that we call a test statistic. So as you might guess from the name, the test statistic has to do with the specific hypothesis test we're carrying out, and it is ultimately a statistic that we compute that measures how well our sample evidence aligns with our belief in H0. All of our test statistics, at least in this chapter that we're going to be examining, have the form. We have a point estimate minus the mean of our sampling distribution, assuming H0 true, divided by the standard deviation of the sampling distribution, assuming the null hypothesis is true. So in other words, if we have our distribution, our sampling distribution, assuming the null hypothesis is true, our test statistic is some random value that's going to land somewhere in here, right? For the sake of illustration, I'll just call it capital T for now. But it's a simple and a compact way of summarizing the sample evidence in a hypothesis test. And depending on our level of significance, we'll find out if it's likely or not. But that's a subject for a next video. So we're going to talk about now how we actually use the test statistics and what a test statistic is telling us.